Today we're going to cover two more of our triangle congruence theorems, and they are called angle side angle and angle angle side, and we abbreviate them using ASA and AAS. So the first theorem would be the angle side angle postulate, or ASA postulate, and it says that, make my pen a little thinner here. We'll try to make it a little shorter this time. If two triangles have two pairs of congruent angles and a congruent side in between, then the triangles are congruent. So what this means is, if you look at these two triangles over here, you can see we have an angle marking right here. We have another angle marking here, and we have a side in the middle. So we actually have enough info to use the angle side angle, or ASA theorem. So your side should always be on the same, the same side as the angles. They should all make a straight line. The other theorem, it still involves two angles and a side, but it could look like this. So that little tick mark does not have to be in between. It could also be on one of the outsides, and it would still be congruent triangles, but we would call that the angle side theorem. It's pretty much going to be the same thing, except we'll change the wording just a little bit. Have two pairs of congruent angles and a congruent side. That's not in between. Then the triangles are congruent. In our first example, right away you should be marking PR as it is a shared side. And I'm looking at my rainbows and both triangles. I see an angle marking, and a side mark that is not in between the angles. So this one would actually be angle, side. The next picture is also angle, side. Again, this tick mark is not in between. If it were, it'd be angle, side, angle, but it's not. So again, we write A, S. In example 3, I can see two angle markings, but unfortunately there's no tick mark, and there's no shared side that we can put our own tick mark in, so we just write not possible. Unfortunately, we don't have enough information to go ahead and say that those triangles are congruent. We don't have enough to use the theorem. And then the last one, number 4, you must put your own angle markings in the vertical angles. Do that first. We have an angle marking, a side mark, another angle mark. We have angle, side, angle. So that's just kind of familiarizing you with a picture and matching the correct theorems to the pictures. We are going to do 2 proofs, but they're pretty short, so it's not too bad. So, as always, you need to make 2 columns, statement and a reason column. And because I don't have a lot of space, instead of recopying that info, I'm just going to write it down here as always. First step is given. And they've already made markings in the picture for you, so that's good. Put a 1 and a 2 right here. We want to go ahead and say that angle 1 and angle 2 are congruent. Because they are vertical angles. If we look at our picture, I see an angle, a side mark, and another angle. So I actually can go ahead and say that the triangles are congruent. And again, just because I don't have a lot of space, I'm just going to draw an arrow. And we would write angle, side, angle. So, not bad. It's a 3-step proof, so it's not too long. All right, we have given. Now this one's going to be a little bit longer. It's a little bit trickier. They are telling us that AB and CD, these 2 lines, are parallel. That does not mean they're congruent. That's not the same thing as a tick mark. But what we can do is if we kind of shade those parallel lines and we shade the transversal, then the angles that are between those shaded lines are going to be congruent. And again, I put a 1 and 2 in here so it's easier to name. And the reason they're congruent is because they are alternate interior angles. So if I look at my picture, I have an angle, I have another angle marking. So somehow I need to get a side marking in here, and this turns out to be a shared side. So we need to write that AC equals itself. And as before, we'll call that the reflexive property. I now have angle marking, side marking. So I can now go ahead and say that the triangles are congruent. By angle, angle, side. If we look at triangle CAT, we actually have an angle side angle theorem. So the other triangle that would fit angle side angle would be this one right here. So since C and G have one rainbow, C has to go with G. So I'll write G above that. A and D both have 2 rainbows, so D goes with A. And then obviously O goes with T. So it would be C, G, D, O. All right, number 8 is just a fill in the blank proof. So we have 2 givens. They've already marked it in the picture for us. So we just fill in the reason. Go ahead and write given. Again, with these parallel lines, we've got to be very careful. So angles 1 and 2 are made using those shaded lines, so they are the angles that are going to be congruent. So we'll write angle 1 is congruent to angle 2. The reason being that if two lines are parallel, then the alternate interior angles are congruent. They're telling us AC equals itself. That should be pretty easy. And if you look at your markings, you actually have enough info to use the angle-side theorem. So therefore the triangles are congruent because of angle-side. So far we have covered the SAS theorem, the SSS theorem, the ASA, and the angle-side. So really all we have left is this HL theorem, which we'll probably cover in a couple days.